Given below are the two statements. One is labeled as assertion and the other is labeled as reason. Okay. The stretching of a spring is determined by the shear modulus of the material of the spring. Okay. Reason. A coil spring of a copper has more tensile strength than that of steel spring. No, this is incorrect. Reason is incorrect. Why it is incorrect, dear students? Because steel has the greater value of modulus of elasticity as compared to copper, right? So reason is incorrect. Yes, the assertion is true, right? So let us see the options here. Yes, we have an option here. Fourth option, that is assertion is true and reason is false, dear students. Option 4 being the correct one. Let us now solve the next question on mechanics of solids, dear students. The amount of elastic potential energy per unit volume of a steel wire. So we are given with the length of the wire, which is 1 meter, and delta L is given by 1 mm, which is 10 to the power minus 3 meter indeed. Okay. Young's modulus is 2 into 10 to the power 11. Okay. Now you know that elastic potential energy per unit volume is given by half multiplied by stress into strain. Okay. We have the value of strain, which is delta L by L. We don't know the value of stress. So we'll use this formula. Young's modulus is equal to stress divided by strain. So this strain would be stress divided by Young's modulus. Strain would be, dear students, stress divided by Young's modulus. So small u is going to be, half, and this is, obviously, rather let us replace this stress. Stress would be, Young's modulus times strain. Okay. We'll replace the value of stress here, which is, Young's modulus times strain multiplied by again strain. Now let us substitute these values. What we are getting here is, okay, this is half. Value of Young's modulus is 2 into 10 to the power 11. Then what is strain? Strain is 10 to the power minus 3. This is strain multiplied by strain. So 10 to the power minus 3 multiplied by 10 to the power minus 3. Obviously we are getting this value as 10 to the power 5. Okay, dear students, right? So in SI unit it is 10 to the power 5, definitely. An easy question, right? Let a wire be suspended from the ceiling. Okay, there is a wire. It is suspended from the ceiling rigid support and stretched by a weight W. Okay, the wire does not have its own weight. It is not given that the wire has its own weight. Okay, so the weight W is hanging from it, right? The longitudinal stress at any point of the cross-sectional area A would be, definitely stress is force upon area, dear students. Force divided by area, which is, W divided by A, dear students. A is the area of cross section, right? So we have option 3 as the correct one, dear students, W by A. The maximum elongation of a steel wire of length 1 meter. So we are given with the steel wire having length 1 meter. If the elastic limit, okay, Young's modulus is, 8 into 10 to the power 8, dear students. And elastic limit is basically the breaking stress. It is 2 into 10 to the power 11, dear students. Wait, if the elastic limit, wait, I have interchanged these values. This is stress, elastic limit is this. Right, dear student, Young's modulus is this. Right. Now we are asked with the elongation. So you know that Young's modulus is actually stress divided by strain. I'll first calculate the strain, then I'll calculate the elongation. Okay. Now Young's modulus is given as 2 into 10 to the power 11. Stress is actually 8 into 10 to the power 8. This would be strain, dear students. Now I'm getting the value of strain as 4 into 10 to the power minus 3. Strain does not have a unit. Now strain is actually the elongation, means change in length divided by the original length, and which is given to be 1 meter. Okay, so the elongation would be 4 into 10 to the power minus 3 meter. In millimeter it would be 4 mm, dear students, right? Option 4 is chosen as the right option, dear students.
Question is, the Young's modulus of steel is twice that of brass. Why is alpha steel is twice, 2 times alpha, twice of alpha brass, this is given. ठीक है भाई, ये given है. 2 wires of the same length and of the same area of cross section, one steel अंदर of brass are, अच्छा 2 wires of same length, तो L1 इसका जो L0 है तो इसका भी L0 है. इनिशियल लेंथ सेम है, सेम क्रॉस सेक्शन एरिया, अगर A है तो इसका भी A है. बहुत बढ़िया. One steel and the other are suspended from the same roof. If we want the lower end of the wires to be at the same level, then the weights added to the steel and brass wire must be in the रेशियो. हम चाहते हैं खींचने के बाद भी ये, जब इसके ऊपर वेट को लटकाया जाएगा तो ये अलग अलग लेंथ से खींचेंगे, लेकिन हमारा क्वेश्चन की रिक्वायरमेंट ये है कि खींचने के बाद इनकी लेंथ बराबर हो. इसका मतलब इसमें एक्सटेंशन भी बराबर हो. डेल्टा 1 L इज इक्वल टू डेल्टा L2. और एक्सटेंशन की बात अगर की जाए तो क्या होगा, यंग्स मॉडुलस गिवन है तो वहाँ से एक्सटेंशन की बात हम कर सकते हैं. और weights added to the steel and must be in the same ratio. We want the lower end and the brass is same level, and the weights added to the, अब weight की बात हमें करनी है तो मतलब mg force by area over delta L over L होता है. This can be written as mg into L over delta L into A. This is y. So from this delta L can be written as, delta L की बात करें बच्चों तो क्या होगा, delta L is mg into L over ya. तो अगर हम इसको इसमें रखेंगे तो क्या आएगा बच्चों, m1g1 मतलब पहले में जो वेट है m1g into L बराबर है y इक्वल है, y अलग है यंग्स मॉडुलस की, जो यंग्स मॉडुलस को y से लिखते हैं बच्चों, यहाँ पर y होना चाहिए. तो बाई y स्टील इनटू एरिया ऑफ क्रॉस सेक्शन मस्ट बी इक्वल टू m2g दूसरे पर लटकाया गया वेट ओवर y ब्रास इनटू a. सो दिस कैंसल्स आउट, ये सारा कैंसिल आउट हो गया. तो स्टील में जो वेट होना चाहिए ओवर जो ब्रास में वेट होना चाहिए, दैट इज इक्वल टू क्या हो जाएगा, ys ओवर yb y ब्रास, एंड ys by y ब्रास is 2. So 2 times 2 is to 1 is the right answer. Second option is correct.